These are your 9-2A notes, solving quadratic equations by graphing. We're going to be doing a little bit of the same. We're going to be graphing these quadratics. We're going to be finding the vertex. We're going to be going through all of the same processes. So I know it seems like we might be going a little bit fast, but we keep going over the same thing. So in equations, solutions are also the x-intercepts of the related function. And sometimes we refer to them as the roots. So solutions, x-intercepts, and roots all mean the same thing. So for a quadratic function, the only difference between a quadratic function and a quadratic equation is we simply replace the y value in the function, saying that we want to graph it. We replace that y value with a 0. If you replace the y value with the 0, that means you're looking for where it crosses the x-axis. So what we're going to do is we're going to graph these functions, and then we're going to interpret when y is equal to 0. And so we're going to be looking for when the y value is 0, where the graph crosses the x-axis. And so in these 3 pictures down below, we have 3 options. We have the option of 2 unique solutions. And my 2 solutions here are the 2 x-intercepts of your graph. This graph crosses the x-axis at 2 spots, and so the solutions of this would be, maybe in this case, -2 and +2. I really don't know where those numbers are, but let's say it's -2 and +2. So those are the solutions. Those are the answers. In the second option here, the vertex is on the x-axis, and so there's only one real solution. Maybe that solution is -2 in this particular case. And in the third option here, you can see that the graph never touches. It doesn't touch the x-axis. It's above it and keeps going up. This would be no real solutions. So you just simply give me the empty set, no solution. Now, all of these could be flipped upside down or anything else. So these are your 3 options. You can have 2 solutions, you can have 1 solution, and you can have no solutions. And you're not always guaranteed that they're going to be nice, pretty whole numbers either. So we'll talk about when that happens too. So we are actually going to graph these problems to find the solutions. So to solve by graphing, here is your checklist of things that you need to do. You're going to write the equation in standard form and set it equal to 0. If you want to put it in vertex form, you're more than welcome to later on to get the graph, but we're going to put it in standard form. You're going to replace the 0 with a y value. So they already have it set equal to 0. We're going to bring in a y because we have to graph. If you're going to graph, you need a y and an x in your form. You're going to graph the related function, and we're going to identify where the graph crosses the x-axis, if at all. If it doesn't, then it's no solution. And sometimes we might have to estimate. So we'll say it's between 2 whole numbers. That's all we have to do there. So you can always refer back to this sort of as a checklist. All right, so we're going to solve the following quadratic equations by graphing. So the very first step is to put it in standard form. So that means to move this 16 over. So we're going to get x squared plus 8x plus 16 equals 0. Okay, the 0 is the x-intercept, right? So that's when my y value is 0. So the next step is to make that 0 a y. And I'm just going to rearrange the equation so that it reads y equals. We're just used to it that way. So what I did there is I replaced this y for 0, and then I just flip-flopped the order in which I wrote that equation. So I did that in the step below. Now that we have the standard form equation, we need to graph it. If you want to put it into vertex form, you're more than welcome to. I'm just going to keep this one as is. And so I'm going to actually, when I look at this one, What multiplies to give me 16 and adds to give me 8 is 4 and 4. And so I actually already have a completed square here. So I'm actually going to put this in the completed square form. I didn't have to bring in a new c. It was already a nice, perfect square. So I have a trained eye for that. I don't know if you would see that right away, but it was easy for me to put that into vertex form. So when you graph these, we have practice graphing as a vertex form. We have practice graphing as a standard form. That's up to you. But I recognized that this was a perfect square trinomial, so I went ahead and put it in vertex form. Now that it's in vertex form, my vertex is -4, 0. Okay, H and K. And so now that I have my vertex, I can go ahead and make my table of values. And my table of values has a vertex of -4, 0 is my vertex. So I can put that on my graph. -4, 0 goes over 4 to the left and 0. And that happens to be my x-intercept. And if that's my vertex, I'm only going to have one solution. I still have to finish the problem because it does say to solve by graphing. So I'm going to keep going. So what's nice about graphing as you go, you kind of make your table and then you graph, I can see that the next two numbers are -5 and -3. So I'm going to use those two values. I know that in the original problem, I have my y-intercept of 16, but I don't feel like going all the way up to 16. So this is where you guys have to start thinking about your graphs. Do you really want to use the ordered pair 0, 16 and -8, 16? I don't think so. That's huge. So it's there, but it's a pretty big number. So I'm not going to use it. I don't want to. If you want to, you can. So I'm going to use -3, which is to the right. It's bigger than -4. And I'm going to use -5 on the other side. And then I'm just going to go one more out. I'm going to go to -2 and -6. Now I'm making those dots on there. Those aren't the ordered pairs. I'm just showing you the values I'm going to use. So I'm going to get rid of those because I don't want you to think that I'm graphing there. So those are the ordered pairs I'm going to use, but I'm going to use symmetry. So I got to find these ordered pairs. So these two are going to give me the same value, and these two ordered pairs are going to give me the same value because they're the same distance away from the vertex. And so to plug in, I'm going to plug in -3 into my new form that I have here. I can plug it into either one. So when I plug in -3, I get y is equal to, I want to do that in a different color. Y equals -3 plus 4 squared plus 0. So I decided to use the vertex form. -3 plus 4 is 1. 1 squared is 1, plus 0 is 1. So y equals 1 here and here. So I have these two ordered pairs. So -5, 1, and -3, 1. And then the third point I'm going to use, or the fourth and fifth point, I should say, I'm going to either plug in -2 or -6. I'm going to plug in -2. So I'm going to use the vertex form. And I'm going to plug in, make x -2, solve, and I end up with 4. And so -2, 4, and -6, 4. -2 goes up 4 units, and -6 is going to go up 4 units. So when it's all said and done, I'm going to connect my parabolic curve, and I can see the graph, and I can identify my solution. So I have one solution, and that solution is -4. Now, what you can do is you can check your answers to these by factoring. We did a whole chapter of factoring. And so I just want to show you that if you were to factor this, we'll come off to the side here. You could check your answer. X squared plus 8x plus 16 equals 0. Whenever you have to solve by factoring, you get it equal to 0. Then we use ZPP. We factor and I say what multiplies to give me 16, adds to give me 8, or what does this factor to? X plus 4 times x plus 4. I have a product that's equal to 0. So I get into that phase where I say one of these numbers is equal to 0. Well, either x plus 4 is equal to 0 or x plus 4 is equal to 0. So there's the same number twice. When I solve by factoring, I get x equals negative 4. So you can find your solutions by factoring, but you can also find your solutions by graphing. Today's lesson is by graphing. I just wanted to bring in that concept of factoring. Bring in the whole reason we factored in chapter 8 was you can find the solutions in chapter 9 quickly without having to graph. But I want you to do it this way for this part of it. So since they tell you you have to graph to solve, it's one of the ways we have to do it. So we can kind of use factoring as a way to check our answers. All right. So that's the first problem. I had one solution and it was negative 4. Let's go on to the next one here. Solve the following by graphing. So the first thing I'm going to do is get it equal to 0. It's already equal to 0. I'm going to replace that y value, or replace that 0 with a y value and rewrite it. So y equals x squared minus 3x minus 10. I don't want to put this into vertex form because that 3, when I take half of it and square it, it would get ugly. So I'm going to go to the old-fashioned standard form. So the first thing I need to find is the vertex. So x equals negative b over 2a. X equals positive 3, because that's the opposite of negative 3, over 2 times 1, which is 3/2 or 1.5. So my vertex is 1.5 something. To find the something, I need to plug 1.5 in for x in both of these cases. And so y equals 1.5 squared minus 3 times 1.5 minus 10. And so when I do that with my calculator, I end up getting give me 1 second. Negative 12.25 as my vertex. So it looks like I need to actually adjust my paper just a little bit. I need to move this down a little bit. I need to continue down here. And so that's 6, 7, 8, 9, 10, 11, negative 12.25. I'm going to make my table of values right here. And my vertex goes right in the middle. So my vertex is 1.5 and negative 12.25. So I'm going to find that on my page. I'm going to go over 1.5 to the right and down to negative 12.25. There's my vertex in green. I'm going to try to color coordinate these. Now, notice on the last slide, I didn't find the axis of symmetry, and I didn't find, domain and range, min and max. We did all that. We can do that later. We will do that on the homework. But right now, just to get to the notes, we're going to just concentrate on the new concept. But I do recognize that my a value is positive, so this is going to be opening up. So if my vertex is below the x-axis and I'm opening up, that tells me that I'm actually going to cross this the x-axis twice. So I've got a fraction here. I don't like it. So I'm not going to go to a fraction. I'm going to go to 0 to the left. And that's 1.5 units away from the vertex. So another 1.5 units away in the other direction would be 3. So I'm going to use 0, 3. Well, 0 is my y-intercept. So if I look at my equation, my y-intercept is 0, negative 10. So 0, negative 10 is going to be here, and so is 3, negative 10. So I'm going to put those on my graph. 0, negative 10, 7, 8, 9, 10. And 3, negative 10 is right next to it. Trying to color coordinate my points so you can see the connection. I need one more point. I don't always have to go outward from these points. I don't have to go out, but I'm going to go out even further. So I'm going to go to -1, 1 unit to the left of 0, and I'll go 1 unit to the left of 3. So these 2 points, -1 and 4, are going to match up. So I'm going to plug in 4 into my equation. Y is equal to 4 squared minus 3 times 4 minus 10. Y is equal to 16 minus 12 minus 10. And when you calculate all of that, 16 minus 12 is 4. 4 minus 10 is -6. And so what I got here is 4 gives me -6. 1, 2, 3, 4, 5, 6. And -1 gives me -6. So you can see it's going to be a ways away before I cross that x-axis. So I might need to go out even further a little bit. So why don't we look at this and say, maybe I could use factoring to help me find those solutions. So let's just go ahead and take x squared minus 3x minus 10, and let's see what would happen if I used that value. What does this factor to when it equals 0? And so what multiplies to give me x squared would be x and x. What multiplies to give me -10, -5, and +2? I've got my answers. So x minus 5 would equal 0, or x plus 2 would equal 0. And so I need to go to 5 and -2. If I go to 5, so I just had to go one more out. If I go to 5 and -2, I will finally get 0 because I solved by factoring to get them. I was a little far out. So 5 is going to give me 0, and so is -2. So now that I have enough points and I know that it's going to cross the x-axis and where it's going to cross the x-axis, I can draw my graph. Okay, there's nothing that says you can't use all of your tools to get your graph. So I found my zeros by factoring. I found where the graph crosses the x-axis by factoring. You could have kept plugging in points. There's more than one way to solve these. But I do want to mention that this function has 2 solutions, and the solutions are -2 and +5. Okay? Another example here. They do take a little bit of time. So we're going to graph this one. And I'm going to replace this with y and rewrite it so it's y equals x squared minus 4x plus 2. I'm going to put this into vertex form just to get you used to that. So it's not perfect. I'm going to move out old c. Y minus 2 plus some space is equal to x squared minus 4x plus some space. This is the day before how you complete the square. I want to change this standard form to vertex form. It all involves using this -4. So my new c value is created by taking the half of the b value and squaring it. So my new c value is going to be -2 squared, which is +4. So we moved out -2 and we brought in +4. When you do that, I get y plus 2 is equal to this whole thing factors to x minus 2 squared. That was the whole reason we did it. And then bring over the -2. Subtract 2 from both sides. Y equals x minus 2 squared minus 2. Lots of 2's there. So now that I have it in vertex form, I can tell you that my vertex is 2, -2. My table of values, my vertex is 2, -2. So if my vertex is 2, -2, that's up 2 and down 2. And we're going to just have to pick points here. So if I pick, I'm going to go with 1. I'm going to use my y-intercept too. So I'm going to pick 1 and 3. Those two will be symmetrical. And then I'm going to use the y-intercept for the other point. And that would be my y-intercept is positive 2. So I'm going to go to positive 2, 0, 2. And if I have 0, 2, I'm going to be at 4, 2 as well. So that I use this y-intercept right here. 0, 2, 4, 2. So now I just got to find point 1 and 3. So when I plug 3 into my vertex form, y is equal to 3 minus 2 squared minus 2. Y is equal to 1 squared minus 2. Y is equal to 1 minus 2. Y equals negative 1. And so I get 1, negative 1, and 3, negative 1. Now I really don't know where it's crossing, but I know that it does cross because I have points above the x-axis. I started below, I'm opening up, and I went across. But you can kind of see where it crosses is kind of not so nice. It wasn't a whole number. So because it didn't cross at a whole number, this is what we do. There are two solutions. They're right here and they're right here, but I don't know what they are. So we just say that there's two solutions, and we describe where they're at. One of them is between 0 and 1. Okay, one of them is 0 point something. And the other one, if I graphed it correctly, is between 3 and 4. I'm looking at the graph and I see that the cross is somewhere between 3 and 4, 3 point something. That's all you have to do. Okay, graphing is not the most accurate way to do these, but sometimes it's the only thing that you can get. Now, if I were to check this with factoring, sometimes you can't factor. And so what that means is it's an ugly number. I can't come up with a number that multiplies to give me 2 and adds to give me negative 4. So this is as good as it gets. The last example is just showing you the same thing. So here's the by graphing, I have the answer to this one. This is the same exact problem. I'm just showing you the actual answer. Okay, so it actually crosses here. We were correct, and then we were here. That's all. The only one I did not show you is when you don't have an answer. So that's where your graph is opening down and it never crosses, or it's opening up and it's already above it. So we can try those in our homework. So your answers, how can you check your solutions to see if they are correct? And then in this one, give me the answer. I already did all the work. You just got to identify it. That's usually what we do, is just identify in this graphing section. So we'll try to be kind to you when we're graphing all these problems. Good luck.